Security engineer. His talk today is the nuts and bolts of security automation at Runtastic. Please give Markus a warm round of applause.
Thanks for the intro. It's great to be back here at the FH Pölten. And the nuts and bolts of security automation of Runtastic. Some facts and figures, and why I'm including this slide. So for the people not from Austria, where Runtastic is very well known, so we're one of the most successful startups, as Alex already said in the intro. We're a fitness tracking app, and what's really surprising to most people is the number of employees. So most of the Austrians I run into is like they think of Florian Schwantner at maybe 10 developers running the business, or they have like this mental picture of I don't know how many developers do you need to run a fitness tracker. The truth is, behind Runtastic, it's around 240 people. It's very international, so we have around people are coming from 38 different countries, and we have 3 different offices. So the main office is in Linz. I'm working from the second biggest office in Vienna, so we are located at the Westbahnhof. And as Alex already mentioned, Adidas bought us 4 years ago. So we are now Adidas Runtastic. So in the end, what brought me to Runtastic was like, so out of the 240 people, almost we have 120 engineers. So if you think about this, to run a successful app, the amount of engineering effort required is really high. So most people think, as I said, it's only a few people. And what really brought me personally to Runtastic is we are all running on Linux. And I'm a huge open source fan personally. And we run a lot of microservices in the backend. So in the end, more than half of our employees are really IT guys. And it's essentially an IT company. And it's a really nice and cool IT company, and I think one of the most interesting ones in Austria to work for, and that's why I essentially ended up there. And the motivation for my talk today is I personally think I'm a very big fan of automation. And why automation? Because it makes security scalable. So if we run, I don't know, instead of 70 microservices, we run 700, automation of security will still scale, right? And also automation, I didn't put this on the slides, but automation normally reduces errors done by developers. In the end, when you walk out of this presentation today, there are 2 open source tools which I really want to promote for you as a security professional, because I think they're very helpful if you're building software. And in the very end of my talk, the last few slides, I'm going to discuss some ideas based on commercial services which we use. So no matter if you have a huge budget or not, open source tools, and in the end, some very brief ideas for other automation tools. My hidden agenda, of course, and I put this on the slides as well, is with a headhunting bonus. We're really craving for developers. So if you want to do ops or developing, one of the things I also want you to take away from today, we are a huge IT company, right? It's not Florian Schwantner and 10 random people. This is my hidden agenda. The first thing, this is the first building block of my talk today, is transport layer security and how to use automation there. And the first picture, and this, who saw this, who knows this picture from somewhere? See a few people raising their hands. So this was part of the The Snowden leaks, and this is not part of our threat model. Yeah, so it's like we don't cover threats such as three-letter agencies. But I think what's really nice about this this picture is how TLS is still used in most of the companies, whereas you have like some kind of reverse proxy, could be Nginx, where you do all the encryption coming from the mobile users, from the web users, and so on. And then you have the data center, in this case the Google Cloud, and everything behind the reverse proxy, your Nginx, is unencrypted. Yeah. So the guys who made this little drawing were very happy about the cause, because we just said, okay, if everything is encrypted here and no magic needed, we just move to the data center, right? And most companies still do this, yeah? So encrypted on the left, and then there's the data center. So Google, Yahoo, and so on, who were apparently affected by this issue, fixed this. For us, just a short reminder, and it's nice to speak in front of a security crowd, is why is TLS important? So transport layer encryption for internal data center traffic. And then normally, it's like when I speak to non-security professionals, I normally flip around the order of these three words. So I normally put integrity first. Why? Even if you don't have sensitive traffic in your data center, it's important to protect the data. So imagine you're sending logs from different servers in your data center around to other services. You really want to protect them from some kind of modification. Could be not related to security and so on. The other thing is speed. Unfortunately, these are PDF slides, so normally I always have this small animation showing that HTTP2 really speeds up things. So the second thing about using TLS is speed, and then obviously you also have security, right? The other thing though is, this is all nice, so you can pitch this, but in the end, TLS, for most of the people who don't have a security background, it's really a nightmare to configure. So it's people spending hours on Stack Overflow posts, going through like OpenSSL comments, and they chain them together until it finally somehow works. The other thing is it just doesn't scale. Yeah, so if we have 70 microservices multiplied by, I don't know, 10, so if like 700 instances, fiddling around manually with these services, this is just not gonna work out. So the thing is, when you want to automate TLS, essentially what you need is a public key infrastructure. We had a look at 4 possible candidates, and this is one of the things you can take away from this talk. You don't have to Google yourself or do the research. Is you just you can profit out of our work. So one obvious candidate for automating PKI stuff is Let's Encrypt. Then Boulder, which is like the basis for Let's Encrypt. DocDec, don't know if anyone ever heard of this, but apparently it's a thing if you're from the Red Hat community. And then finally CFSSL. Why didn't we just use Let's Encrypt? So Let's Encrypt, I guess most of you are using Let's Encrypt already for some case or the other. If you run Let's Encrypt for all your internal services, one thing which we thought is not really nice is because of certificate transparency, you expose all your internal hosts. So we have all these services, and normally they're very descriptive. So you could say, like, I don't know, Rails web service 001, and so on and so on. So the host names are really speaking for themselves, and we didn't want to make this public. Yeah. So if we have Let's Encrypt running on all our backend services, you would normally, through certificate transparency, also leak all your internal services and provide an attacker additional information. Also, there are no client certificates, which are really nice if you work with authentication. Then we had a look at Boulder. So we thought, okay, the general idea of Let's Encrypt is really nice. if you just use Boulder, which is the basis for Let's Encrypt, which is completely open source, and use it for our case, this would be nice. Didn't scale because there were so many modifications. We basically had to fork Boulder to use it, so that was not an option. DocDec, there's really no active development, and it has a high focus on Fedora, Linux, and Red Hat. So in the end, one key takeaway from today, CFSSL. It's a really nice tool. It's from Cloudflare, so I think most of you have heard about Cloudflare. So they are also producing a number of high-quality open source projects. It's written in Go. I think most of the things in security are written in Go nowadays, maybe Rust in a couple of months or years to come, and then another popular, hypey programming language. But it's also nice that it's included in Ubuntu. And what CFSSL essentially does is it really helps you with creating TLS certificates, and also helps you with running an API server. So in the end, all you need is like 2 binaries from this tool. So you can think of it like a wrapper for OpenSSL. I didn't put any examples for the JSON stuff because it's pretty straightforward. But you use this one command to generate a new CA, pass this to this other tool, which then creates the actual certificates out of the JSON output from the first thing. So it's one comment to create the CA, and then one comment to just with the same binary to run an API server with the certificates, and then finally you just use the tool and create certificates. So it's essentially, if you compare this to running OpenSSL, it's really, really a major improvement. So this is really, really fast, and you have your own PKI server. So the next obvious thing is like, so okay, this is a nice proof of concept. You can fiddle around with it for a couple of minutes, but essentially, if you want to use it in production, there are a few things to consider. One is you can define API secrets, obviously random. You can whitelist certain host names. You can, for example, say this API endpoint is only allowed to sign certificates for a certain domain. And you can also define cryptographic algorithms and lifetime and so on. Revocation, I won't go into depth there. It's also supported, but that's a really, really tricky topic. Yeah. How we use CFSSL at Runtastic. So essentially, what we do is like we use an open source tool and really run a PKI, which is meets our security standards without spending like 40 or 80K for a hardware security module from a vendor. Yeah. So essentially, we have a root CA, which we encrypt and keep offline. And then we have a number of API intermediate certificates, and they then sign the leaf certificates. And yeah, obviously, the root CA is valid for a longer period of time, the intermediates for a shorter period of time, and then the leaves, we are kind of conservatives there. We keep them active for 1 year. And yeah, this is basically how we structure it. And with CFSSL, this is really easy to set up. What we essentially do, and this is the big benefit for our developers or operation guys, is so we are heavily focused on Chef, which is this automation tool. I think most of you know it. It's similar to Ansible, Puppet, and so on. So essentially, our infrastructure people, they just set 2 attributes at each of the instances. If they want to have a server certificate or a client certificate, it's automatically generated. And they don't have to care about who is signing what, is the order okay, which cryptographic algorithm to use, and so on. So in the end, what we want to provide as a security team is automation that's so simple for the people that they can just use TLS without worrying about the underlying implementation details. One example use case is for us authenticated and protected logging. So everything is properly encrypted in our DC. So if you have this picture mentally in your head from the Google DC in the end, in the beginning, there are some parts which can be easily covered with this setup. So this was the first thing. So if you take one thing away, it's like TLS is important. It's tricky though, but CFSSL is really a nice and cool tool. Use this. The other thing which is often a challenge with large infrastructure things is how you manage your credentials. And with credentials, I mean like DB usernames, API tokens, and so on. So every backend service for us needs to use them. So obviously the worst thing to do, and luckily none of our developers did this, is to just hard code it in the source code. Yeah? And people often make this mistake. I think most of you are aware of this tool called GitDrop. There are a couple of those tools, also including Metasploit, where you just hunt credentials committed to GitHub repos. Yeah? So this is obviously very bad. So never ever do this. The workaround, which is very common, is you just use environment variables via dot files and don't commit them into Git. And the issue here is, which we faced, is the deployment and management of these secret files. Yeah? It's hard to automate. They might not be consistent. And you have these dot files spread over all your services. So think again about our infrastructure, so 70 different microservices, and you have all these different dot files with secrets in them. And this is why the only way forward is to use key vaults. If you're already running on a cloud service, they are available on AWS, Azure, Google Cloud, and so on. For on-premise, this was the option for us. We use a centralized key vault, and the idea of a key vault, if you never heard about the concept, is think about something like a password manager, where you have like an encrypted file protecting all your secrets with an API on top. Yeah, so the engineers, on one hand, can edit all the secrets, and then the services consume the secrets via the API. And there's also very nice stuff which can be completely automated. Like, for example, HashiCorp Vault, the vault we are using, is also, it's an open source project, also written in Go, has a number of different secret engines. And one of the things it can do is you just provide a vault with root privileges on MySQL, and it automatically generates dynamic secrets for all the backend services, right? So instead of you create a user on your database, then you send these database users to somebody, and then this other somebody configures them on their service, is you just tell Vault, look, there's an application, it needs access to the MySQL database with these permissions, and then Vault is rotating the secrets for you. So it's just creating a user and also rotating the secrets, completely transparent to the app, and they are injected to the application. So you don't need to worry about setting strong passwords for your database engines anymore. It's just completely automated. So that's a huge win, I think, from a SecOps perspective. Things we had at Runtastic. So one challenge was to make the setup highly available. Because the thing is, with Vault, because it's centralized, if this service dies, basically all your services starve, yeah, because they don't have secrets, and yeah, you don't want to go down this road, yeah, because you you centralize your secrets, but you also create a single point of failure. So we use it with auto-unseal with a cloud provider, where we basically use a key management service in the cloud, which via handshake unlocks our Vault instance. So we have a number of instances of Vault which are really resilient to services dying. One thing we are using it for is Kubernetes, where so we are running some of the services on Kubernetes, and it's very easy for the developers to just define policies, set the credentials, and these credentials are then automatically injected into the containers. And this is was a huge step forward to us, and I think this is, whenever you run multiple services, even for small setups, use a credential vault. And the last thing, also in the outline today, is like other automation ideas, and just some basic ideas of things we are using. And build pipeline checks, I think this is a huge topic, and you could make, like, I don't know, a series of talks around it. But this is really, I think, one of the most essential things to develop software nowadays, where you go away from defining a secure software development lifecycle, where like security steps in, comes with the checklists and says, okay, this build looks good. Okay, here's the green check mark, let's move on. If you build stuff into your build pipeline, so we are using Jenkins, for example, you do automated checks. So what are ideas, for example? Have there been secrets committed to the repo? Then tell the developer this is not a good idea. Run some static or dynamic code analysis, and so on. For us, and as I said, there are build pipeline ideas almost in definite possibilities. One thing we are doing is like we want to force or nudge. I think force is a very hard word, but nudge our developers to always keep the libraries up to date. And what we do is, like, if they make a pull request, they automatically get a comment and telling them, for example, your Ruby version is not up to date, please update. Yeah. And this is, I think, in a sense, the automation here is you go away from a HISA-driven development to continuous development. What do I mean by HISA-driven? Security patching is like you run services on Ruby, somebody wakes up and reads the thing, it's like, new Ruby vulnerability. The people go nuts. You get like 20 people together. It's like, we need to fix this Ruby stuff. I read it on HISA. It's really super important. And then everyone is panicky. They patch the services, and then they spread out again, and it's business as usual. So if you just stop reading HISA and keep your applications up to date, that's better, obviously. Yeah. So, and this is what we want to do, is like just nudge them, saying, look, you missed a minor version, please update it now. The risk, if you don't do this continuously or automated, is once you have this HISA news article or Spectre or whatnot, then normally it's too late and the effort is really high. Other things we were facing was security alerts. I think, yes, everyone in security is just overflowing, yeah, with these alerts, and you add another component or another vendor brings another tool, and it's just super tricky that you handle all this information. So one of the things we are using, and I'm really glad, this is one of the commercial services we opted for, is OpsGenie, which also integrates in our Slack, and this is really cool. So we have this in our Slack channels, and we can acknowledge the alerts, so you can see somebody else on the security team already picked this up, and you can upvote it, escalate it, and quickly close the things. Yeah, and we went one step further. So I'm leaking my internal username here at Runtastic. through marriage, I'm very, I used to be called Markus Huber before, now I'm Markus Donko-Huber. And because of this, I got a really nice acronym, which is MAD. So most people at Runtastic, so outside of this small security community, at Runtastic, they know me as MAD. So it's an example here. One of the alerts we had, so we are monitoring, is somebody roaming countries quickly with accessing their VPN, or are they having problems logging in? And then what we used to do was like, we chatted the people up and said, look, do you have issues with your VPN account or with your SSH account? It seems that you're producing a high number of alerts. And what we are doing now, and this was always, we were sometimes too late, we didn't respond fast enough. What we did is we automated this, we wrote a small Slack bot, and it's just chatting up the people. So it's completely automated, we don't have to care, and our response time increased immediately. And also we only get all the false positives out. Yeah, so that really to the minute using up all my time. So I guess we're gonna have to take the questions outside. Yeah, automate DLS. It's super easy with CFSSL. Use it, set it once and use it for kind of forever until your CA runs out, and then you get panicky again. No, but seriously, do this. You will profit for a long time. Credential handling, use Vault. If you haven't heard about CFSL or Vault before, both are super cool, nice tools that help you in the daily work. Build pipelines for the win, so endless possibilities there. And yeah, alert handling, really, I really suggest to really pay for an external service to streamline this, or also maybe to automate some of the stuff. Yeah, thank you for being here. I'm happy to, as I said, answer any questions afterwards. I'm going to be around for a bit. You can also write me an email, matt@runtastic.com. If you happen to be a developer, just reference me, right? It's like, that's the thing, it's like just don't go there and then chat me up 2 months later and say, yeah, I'm here, it was really inspiring talk. No. Reference me, I crave for the money, I have 2 children. Yeah. Okay, thanks everyone, and I'm happy to answer any questions later on.